Hey everyone. So let's talk about the experimental design and safety precautions I did for oxidation reduction reaction. Uh, so as usual, wearing non-synthetic clothes, wearing gloves, glasses, an apron as well this time. Use hot pad as well for just because I don't burn myself or drop the beaker for some reason. Uh, and as usual, I have fire extinguisher behind my back. I have distilled water next to me. I have a spray bottle to sprinkle on my eye, and yes, pretty much all that. Uh, Experimental design was pretty much straightforward. There was nothing to set up. Using for doing the 15 ml actite solution and put it into hydrogen peroxide plus tartar solution. I cream of tartar solution. I used 10 milliliter of cylinder, and I used that to put 15 ml of iron octet solution. So coming back to the results, I just cleaned up my lab. Uh, I didn't know I had to show it in the video. But I did take the pictures, so I'll put the pictures into the video. So it took about roughly roughly 30 seconds for color to show up, and the color that I saw was light green. The initial temperature was 70 degrees Celsius of iron 2 oxide, and color was clean. As soon as I put it, the temperature rose up to 75. I think this I measured it around 14 seconds, and this I measured around 25 seconds because since the thermometer was on the in the beaker, and the readings are very small. It takes time to like hold it straight and keep the solution stirring, look at the timer and write down the temperature. So it took some time. uh, I changed the temperature column to degree Fahrenheit because the thermometer was in degree Fahrenheit. Color was light green. There was a slight increase in temperature, so on and so forth. So this concludes the results section. It was light green all the way, so just didn't notice any change once it changed. Initially, the color of the hydrogen peroxide and cream of tartar was whitish because of the cream of tartar, but once a reaction started happening, you could see the changes. So for the critical thinking part, uh, how the color change explain the temperature change and the color change as the reaction proceeded. So when we mixed hydrogen peroxide with tartar, uh, I think there were no bubbles in the solution. Uh, but after mixing the solution from the flask, uh, 15 ml of iron oxide acted solution in a flask, I could see the small bubbles coming out, which upon some investigation, I found that it's releasing CO2. And because it's releasing CO2, it would, uh, using my vague knowledge of enthalpy, it would be an endothermic reaction, hence it is absorbing heat. Uh, and that is the reason why there was a okay why okay that is the reason why there was a slight temperature change. I saw temperature change of about 10 degree Fahrenheit. And to do with the color, that is the color of the iron 2 oxide uh, when mixed in the hydrogen peroxide and tartar solution. So if you look at the final equation after the oxidation, it's Fe2, it's iron 3 oxide, and this iron 3 oxide has the property, like in between iron 2 and iron 3 oxide, the property shows that the color is the uh, light green due to the excess of ferrous and oxygen atoms, oxygen compound. So that is my critical thinking part. I'm not fully uh, satisfied with my explanation of color, but I think certain colors just exist in the nature, or iron 2 and iron 3 oxides have that color, I guess. Uh, that would be my explanation for critical thinking. I do realize I'm not fully clear on that, but again, it's critical thinking prompt, and I just thought of it like 10 minutes back. Now, for the self reflection part, I'm gonna pull up the module objectives. Okay, so these are the three module objectives that was that I that that I focus on during this experiment. So the first one was to validate experimental observation using theory. So in the theory, we studied all about half reaction, oxidation, and reduction. How oxidation causes losing of an electron. Oh, that could be the reason why the color change. I just thought of it. Uh, the reduction causes the gaining of an electron, and how half reaction takes place. So by studying the solution of steel wool along with a vinegar and heating it up, uh, I studied the process of reduction, and when we mixed it together with and when we mixed hydrogen peroxide and the filtered solution and the cream of tartar together, noted the temperature and color changed, studied the how the half cell reaction and the half cell reaction oxidation took place. Now, classify observation as evidence of physical or chemical changes. So, the change in the color would be would be chemical change, while the change in the temperature would be the physical change. Excuse me. And assert the importance of situational awareness in laboratory. Situational awareness is extremely important. Uh, One, situational awareness comes from your attentive mind, and how often have you dealt with such situations before? Like I have dealt with vinegar before for some cooking purposes, so I know how vinegar smells, and what to do when it spills, and so far and so forth. Hydrogen peroxide, I had not dealt with it before. If I'm not mistaken, hydrogen peroxide is used for cleaning up your wounds, I guess. Not entirely sure, but I think I've seen it on Walmart aisles a lot. Uh, but the importance of situational awareness in laboratory work is extremely important. You have to make sure that your work area is clean, and while moving around, you don't spill or break any beakers or anything. And if you do, you are you're pre aware of or know the steps of how to handle that situation. And for that purposes, I propose to read STS. And I think that's about it. Uh, my thoughts on this experiment was that I was slightly hesitant towards the color of the my final product, but I think it's the correct color. Eventually, it turned out right. I was expecting it to be red color because uh, the uh, first page of the lab module was of rusty color and everything. So I thought maybe we're going to do something with rust. So I was expecting reddish color, but I achieved light greenish color, and that is could be due to slight rusting or due to oxidation and due to the loss of electrons. With this, thank you for watching the video. Bye bye.